welcome to Math in With. In today's video, I'll be discussing a question from CSIRNet 2019 June session. This question is from the chapter Vector Space and this is a part C question, so it is going to have multiple correct options. So let us see the question. Let Px is a polynomial be a non-constant polynomial of degree n greater or equals to 1. Consider the polynomial Qx, which is integration of pt with respect to t from the limit 0 to x, and Rx, which is the derivative of Px. Let V denote the real vector space of all polynomials in X. Then which of the following are true? Q and R are linearly independent in V. Q and R are linearly dependent in V. X power n belongs to the linear span of Q and R. X power n plus 1 belongs to the linear span of Q and R. So, two polynomials are given, Qx and Rx. These two polynomials are given. We need to check whether Q and R are linearly dependent or linearly independent. Next, we need to check whether x power n belongs to the linear span of Q and R and whether x power n plus 1 belongs to the linear span of Q and R. Okay. So, first let us see Qx and Rx. So, Qx is given as integration 0 to x, pt means a0 plus a1t plus a2t square up to an minus 1 t power n minus 1 an t power n dt. So, after integrating and putting the upper limits minus lower limits, we will get a0 x plus a1 x square by 2 plus a2 x cube by 3 up to a n minus 1 x power n divided by n plus an x power n divided by n plus 1. So, after putting this 0, all those terms from 0 will get cancelled out since the whole thing will be 0. This is Qx. And Rx will be derivative of this Px. So, it will be first a1 derivative of this will be 0, derivative of this will be a1, derivative of this will be 2a2x up to derivative of this will be n minus 1 an minus 1 x power n minus 2, and derivative of this will be n an x power n minus 1. So, clearly, what is the degree of Qx? Degree of Qx is n plus 1. And what is degree of Rx? Degree of Rx is n minus 1. So, degree of Q equals to n plus 1 and degree of R equals to n minus 1. So, two different degree polynomial are always linearly independent. Two different degree polynomial are always linearly independent. So, Qx and Rx are linearly independent. So, here option 1 is true and option 2 is false. So, 1 is true and 2 is false. Now, let us check x power n, whether x power n belongs to Qr and whether x power n plus 1 belongs to linear span of Q and R. So first let us see the linear span of Q and R. So that will be Q C1Q C2R. This is equals to C1. Q means A naught x, A1 by 2 x square, A2 by 3 x cube up to an minus 1 by n x power n plus an n plus 1 x power n plus 1 plus, if we write Rx, it will be A1 to A2x up to n minus 1 a n minus 1 x power n minus 1 n a n x power, here it will be n minus 2, so x power n minus 1. So if first we take the constant term, it will be, this is the only constant term, so it will be C2A1. Next, taking the power coefficient of x, it will be C1A0 plus 2C2A2x. Next, if we take the coefficient of x square, it will be C1 by 2 A1 plus 3C2 A3 x square. So continuing like this, we will get the coefficient of x power n minus 2 as C1 into a n minus 2 divided by n minus 1 plus, from here we will get n C2 an x power n minus 1 plus, from here we will get coefficient of x power n and coefficient of x power n minus 1. There is no x power n and x power n plus 1 here, so coefficient will be from here. So it is C1 a n minus 1 divided by n x power n plus C1 a n n plus 1 x power n plus 1. Okay. So if x power n belongs to the linear span of QR, so we can write this equals to x power n. So suppose let us name this expression as 1. So 1 will be equals to x power n. So if we compare the coefficient of both sides, comparing the coefficient of x power n and x power n plus 1, we will going to get, so here what we have, the coefficient of x power n is 1 and the coefficient of x power n plus 1 is 0. So we are going to get C1 a n minus 1 by n equals to 1 and C1 a n n plus 1 equals to 0. Okay. So here we should have C1 equals to n by a n minus 1. From here we should have C1 equals to 0. Why? Since the degree of Qx, the degree of Px is n, which can't be 0, which greater than 1. So the coefficient of x power n can never be 0. So a not equals to 0. So C1 has to be 0. So from here we are getting a C1 which is non-zero, but here we are getting a C1 which is 0. So this is a contradiction. So what is the conclusion? Conclusion is that x power n doesn't belongs to the linear span of Q and R. Okay. Next, we need to check whether x power n plus 1 belongs to the linear span of Q and R. So for this, 1 has to be equals to x power n plus 1. So if we consider the coefficient again, same as previous, comparing the coefficient of x power n and x power n plus 1, what we will get? We will get here the coefficient of x power n is 0 and the coefficient of x power n plus 1 equals to 1. So we are going to get C1 dot a n minus 1 by n equals to 0. Comparing the coefficient from this, here coefficient of x power n is C1 a n minus 1 by n. So we are writing this equals to 0, and the coefficient C1 a n plus 1, this is equals to 1. So from here we should get n plus 1 divided by a, and from here either C1 is 0 or a n minus 1 equals to 0. But in the question it is not given that a n minus 1 is necessarily equals to 0. So we need to consider this case, because a n minus 1 may not be not equals to 0 since it is not given in the question. So from here we are getting C1 equals to 0, and from here we are getting a non-zero quantity. So this is a contradiction because we are getting different values for C1. So x power n plus 1 doesn't belongs to Q plus R. So option 3 and 4 both are false options. So in this question we got 1 is the correct option, 2 is the false option, 3 and 4 both are the false options. So the correct options here are only the option 1. Okay. So thanks for watching this video and subscribe to the channel Math in Pen. Thank you.